Hi guys, this is the last part of the Edexcel June 2017 Foundation Paper 1. I have completed question 1 to 20 on my previous videos. Please go and have a look on the playlist at your own time. So let's do question 21. So for this question then, we're told the scatter graph shows the maximum temperature and the number of hours of sunshine in 14 British towns on one day. Right, so we've got all these marks here which represent different towns in Britain. So on this side we have temperature, and on this side we have number of hours of sunshine. We're told one of the points is an outlier. Write down the coordinates of this point. So coordinates mean the x and y value of that particular point. Now the outlier, it means a point that does not follow the trend. Now if we look at this, we can see the trend is going this way, but this particular one is just on its own there. So we say that point is an outlier. Now what we need to do is read on the x-axis. So from there to there is 11. That means halfway is 10. And this way from there to there is 20. That means halfway is 19. So the coordinate of this outlier is 10 and 19. And for B, we're told for all other points, write down the type of correlation. So correlation is the relationship between these two variables. The variables are the temperature and numbers of hours of sunshine. So what's their relationship? Well, we can see that as we go up, the numbers of hours of sunshine is increasing. So we have a positive correlation. And now for C, we're told on the same day in another British town, the maximum temperature was 16.4 degrees centigrade. Estimate the number of hours of sunshine in this town on this day. So we need to find what are the numbers of sunshine when the temperature is 16.4. So before you do that, you need to establish the scale. We can see from there to there is 17. So that's 1. It's actually easy if you just take 2 points. So 2 divide by, on this side, 2 divide by how many squares are there? 1, 2, there's 10 squares. So 2 divided by 10 is 0.2. That means every square represents 0.2. So 16.4 is over there. Now we need to estimate the numbers of hours of sunshine. Don't just go there and bring the line down here and then read the numbers of sunshine. No, that will not work, because some people will go up there and then come down. Some people will go right in the middle and come down. So what you need to do is find the line of best fit for this graph. We need to get ruler and a pencil and draw the line. So let's just do that here. Now the way to do this is to get roughly the number of equal points on each side of the line. At the moment I can see it's heavy on this side, 1, 2, 3, 4, 5, 6, and on this side we've got 1, 2. So what I need to do is slightly move my line. Now when you draw this, of course, with your ruler, you have the ability to adjust it before you can actually draw the line. So 1, 2, 1, 2, 3, 4, 5. I'm going to move it back a little bit. So roughly there, I think that should be okay. And now what you need to do is go along 16.4 right there. Again, you do need a line, so I'm going to get a line again. So if we go down that way, and then we need to go down this way, and the scale is the same as the y-axis scale. So from there to there is 12, and each room is 0.2, so that means 12.8. So the number of hours is 12.8, which we're going to say is roughly 13 hours, because we are estimating. A weatherman says temperatures are higher on days when there is more sunshine. Does the graph support what the weathermen say? Give a reason for your answer. Of course it does support, because we did say earlier on, the higher the temperature, when the temperature increase, we have more hours or more numbers of hours of sunshine. So as the temperature increase, the number of sunshine increase. So yes, the weatherman is right. So for question 22, we are told to express 56 as the product of its prime factors. What we need to do is a prime factor tree, and then every time we come across a prime number, we circle it. So we start with 56. You need to be good with your timetable, otherwise you can start with a 2 if you like, but I know 56 is 7 times 8, and 7 is a prime number, so I'm going to circle it. And then I can do 2 times 4. 2 is a prime number, so I'm going to circle it. And then again I can do 2 times 2. 2 is a prime number, so I will circle both of them. So 56 as a product of its prime factor is equal to 2 times 2 times 2 times 7. You can also write this as 2 to the power 3 times 7. Now question 23, we're asked to work out 54.6 times 4.3. What we can do here is just estimate what the answer could be. So we can do this as 50 times 4. So we're just rounding the numbers up to get an idea of what the number should be. So 50 times 4 is 200. Now let's do the multiplication of this. Now I'm going to use the grid method. So I have here 50, and then I have I have 500, I have then 40, and I have 6. So I have broken this number down as in 500, 40, and 6. So just do that. And then this other number 4.3, I can do 40 and then 3. And now what I can do is just multiply those numbers up. So I've got 40 times 500, 4 times 5 is 20, and then I've got the 3 zeros, and then 3 times 500 is 1500. So try to line these numbers up so it's easy to add at the end of your multiplication. So 40 times 40, so 4 times 4 is 16, and then I've got the 2 zeros. 3 times 40, that's 120, so that's 120 here. 40 times 6, 4 times 6 is 24, so that's 240. 3 times 6 is 18. And once you're done with this, you can add all your numbers up. So let's have a look. Here we have 0 and 0, 0 and 0, 0 and 5 is 5, 0 and 1 is 1, and then I've got my 2, and then here 0 plus 0 is 0, 0 plus 2, 2, 6 plus 1 is 7, and I've got my 1, and then I've got 0 plus 8 is 8, 4 plus 1 is 5, and 2 comes down on its own. Once you're done with this, then you add all these numbers up. So I've got 21500, and I'm going to add 1, so 0, 2, 7, 1, and I'm going to add 258. Add all these numbers up. 0 plus 0 plus 8 is 8, 0 plus 2 plus 5 is 7, 5 plus 7 is 12, plus 2 is 14, carry over the 1, and then that's 1 plus 1, 2, plus that 1 is 3, and then 2 comes down here. Now once you've got to this point, you might wonder where the decimal should be. Now this is when this estimate come in handy. So I know it should be roughly 200, but I did underestimate my numbers, so I expect a real answer should be higher than 200. So I know that's going to be 234, so my decimal goes right there. Now the other way of doing this is counting how many decimals there are after each number. There is one decimal number here, one number after the decimal here, there is one number after the decimal here. So in total there should be 2 numbers after the decimal, and that works here too. But this is the best way to do it. Estimate your answer first. Now for 24, we have this some sort of square. We're told the area of square ABCD is 10 centimeters square. Show that x squared plus 6x equals 1. So we have this square and we need to find area. All you have to do is just multiply out the small sections. So we can do this square here, which is 3 times 3. So this one is 3 times 3, which is equal to 9 centimeters squared. This small one here, 3 times x, which is going to be 3x centimeters squared. And this one here is 3 times x, so that is going to be 3x centimeters squared. And this one is x times x, so that's going to be x squared. So the total area then, so area is going to be equal to, well, let's add all the x squared, and then there's only one of them, and then we can add the x's, so 3x plus 3x, that's going to be 6x, and then we have plus 9. But we're told area is 10, so what do we need to do? We just need to make x squared plus 6x plus 9 is equal to 10. And then if we rearrange, we can see we've got this part now, so that means we just need to get rid of that 9. So take away 9 both sides, then we get x squared plus 6x equals to, well, 9 take away 9 is 0, 10 take away 9 is 1, and that is what we are asked to show. Now for 25, we are told this rectangular frame is made from 5 straight pieces of metal. So one piece there, one piece there, one piece there, piece there, and one piece there. So we know it's rectangular, so that means this side is going to be 5 meters, that side is going to be 12 meters. Now we don't have the diagonal piece of metal, we don't know what size that is, but we are told it's rectangular. So the question goes on to say the weight of the metal is 1.5 kilogram per meter. Work out the total weight of the metal in the frame. So in order to find the total weight of the frame, we need to find this diagonal. Now we can use the Pythagoras to do that. So we know the longest one, the hypotenuse, is going to be that. So we're using this triangle, and we can say this one is A, this one is B. So what we can do here is C squared is equal to A squared plus B squared. Now C squared is what we're looking for, and then A squared is going to be 12 squared plus 5 squared. So this will give you C squared equals to 144 plus 25. So this means C squared is equal to 169. C is going to be square root of 169, which is 13. So that is 13 meters. Now then we have got the total length for this frame. So total length is equal to 5 plus 5 plus 12 plus 12, and then plus the 13. So 5 plus 5 is 10, plus this 2 is 24, so that's 34, plus 10, 44, plus 3, that's 47. So the total length is 47 meters. Now in order to find out the total weight, then all we have to do is just multiply 47 times 1.5, because we're told 1 meter, let's just write it here, 1 meter is equal to 1.5 kilogram. So therefore 47 meters is going to be equal to 1.5 kilogram times 47. That's going to be equal to 70.5 kilograms. So for question 26, we're told the equation of the line L1 is y equals 3x minus 2. The equation of the line L2 is 3y minus 9x plus 5 is equal to 0. Show that these two lines are parallel. So for lines to be parallel, what needs to happen? They need to have the same gradient. Now, from this equation of a line, y equals mx plus c, m is a gradient. So for line 1, L1, m is equal to 3. This is already been arranged in that form, y equals mx plus c. So we can see m is equal to 3. Now what we need to do is rearrange line 2 to have y the subject. So let's do that. What we have here is 3y minus 9x plus 5 equals to 0. First thing what we want to do is remove everything and have y on one side. So we can add 9x and then take away 5 both sides. So plus 9x, take away 5 to get rid of minus 9x plus 5. So now what we have is 3y equals to 9x minus 5. Therefore y is equal to 9x over 3 minus 5 over 3. So therefore y is equal to 9 over 3 is 3, so that is 3x minus 5 over 3. So L2 has the same gradient. L2, m is equal to 3, so that's m2, and that's m1. So therefore m1 is equal to m2. This means they are parallel lines. Now for question 27, then we have a vector question. We're told ABCD is a parallelogram. The diagonals of the parallelogram intersect at O. OA is equal to A, that's given. OB is equal to B. Find in terms of B the vector DB. So DB, it means from there to there. So this vector is going that way. What you need to know is properties of shapes here. So we know the parallelogram will the diagonals will intersect at the center of the parallelogram. That means this line DO is the same as B and is going to be going in the same direction as B. So this vector here is also B. And vector CO is the same as A. So to find vector DB then, so DB is going to be equal to B plus B, which is 2B. For part B, find in terms of A and B the vector AB. That means we start from A and end our journey at B. So AB is from there to there. In order to get to AB, I need to go either this way and then that way. And that's the easiest way because we don't know what that one is. We can find it, but the quickest way is just to go that way and that way. Now, A is going in that direction. That means I'm going the other way. So, going from A to B is going to be negative A plus B. For C, find in terms of A and B the vector AD. So, AD is this one. So, how do I go to AD? In that direction, basically. So, AD is going to be equal to going negative A and then negative B. So that's negative A, negative B, because I'm going in the other direction. And that's the answer for this question. So thank you guys. This paper is now completed. I'm now going to start paper 2. So if you have enjoyed this video, please remember to like and subscribe. Bye for now.